Next is operations on sets. Operations on sets. So the first one is union of sets. So first we see examples. Suppose that A is equal to 1, 2, 3 and 4. And the next set is 2, 3, 5, 6. So the union of sets means a set in which all the elements of both the sets will lie. So union of sets A union B. The U is the symbol of union of sets. So A union B means union of set is a set in which all the elements of A and B will lie, but the condition is that the element is always written in ones. Means 1, 1, 2, 2. So we write 2 one time. 3, 3, this is 3, 4, 5 and 6. So 1, 2, 3, 4, 5, 6. We see that 2, 3, 2, 3 is the common elements which lie in A as well as in B, and 1, 1, 4, 4, 5 and 6 are the different elements which lie either in A or in B. So a union of set means, definition is that if A and B are two sets, then the union of sets A and B is a set in which all the elements of A and B lie. But we write only one time. Only one time. Means union of A and B is a set in which all the elements of A and B will lie. This is the union, and the next one is that intersection. Intersection of sets. Suppose that we again write this example. A is equal to 1, 2, 3 and 4, and B is equal to 2, 3, 4 and 5. So intersection is the common point which lie in both the sets. So here the common element which lie in both A as well as B. So A intersection B, this is the symbol of intersection. So A intersection B means the common element. So 2 lies in both the sets. So 2 and 3 3 and 4, 4. So 2, 3, 4. This is the set which is A intersection B. So A intersection B is the set. So A intersection B is a set in which the common elements of A and B will lie. So 2, 3, 4 are the common elements. So this is A intersection B. So the definition of intersection is if A and B are two sets, then the intersection of A and B is a set in which the common element of both the sets lie, and it is represented as this symbol. So this is A intersection B. So difference of sets. Suppose A is equal to 1, 2, 3, 4, 5 and B is equal to 2, 3, 6, 7. So the difference of sets is, suppose that A minus B. So the elements of A which do not lie in B, we will write the set of the elements which do not lie in B. In other way, we can subtract the elements. So 2 is common, so cancel out. 3 is common, so cancel out. So the elements 1, 4 and 5. So 1, 4, 5 elements of A which do not lie in B. So A minus B. Suppose we have to find B minus A. So we will check the elements of B which do not lie in A. So 2, 3 is the common. So 6 and 7. So 6 and 7, the elements which do not lie in A. Means A minus B. So we have to see the elements of A which do not lie in B. And if we have to find B minus A, so we see the elements of B which do not lie in A. So this is A minus B, the difference of sets A minus B, and this is the B minus A. So this is the difference of sets. Similarly, the complement of set. So complement of set means just like the difference but with respect to universal set. Suppose that A is equal to 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And the universal set of this set is suppose 1, 2, 3, 4, 5, 6 and dash of set A is equal to u minus A, means just like the same as the difference of sets, but in difference of sets we subtract one set from the other set, and in the complement of set the set is subtracted from universal set, and the universal set are different. We take universal set with respect to the given set. So u minus A means we have to check the elements which lie in U but do not lie in A. So if we cancel out 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, so we see that 6 and 7. So 6 and 7 are the elements which lie in U but do not lie in A. So the complement of A is equal to the set in which 6 and 7 are the elements. 6 and 7 are the elements. So Venn diagrams the Venn diagrams is a way to represent the sets and their relation between other sets and universal sets. So, suppose that A is equal to a set 1, 2, 3, 4, and U is the universal set 1, 2, 3, 4, 5, 6, and 7. We assume universal set. So, by this representation, we can show the set and the universal set. This is U, this is A, circle, A in which 1, 2, 3, 4 lie, 1, 2, 3, 4, and the rest of the elements 5 and 6 and 7, wherever you can write. So Venn diagram is a representation of, is a way of representation of sets and their relation between other sets if the sets are given. So Venn diagram is usually, in Venn diagram we usually use a circles as sets and rectangular shape as universal set. So Venn diagram is a way of representation of sets and their relationship. Suppose that A is 1, 2, 3, 4, 1, 2, 3, 4, and B is 1, 2, 3, 4, 5, 6, and U is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can represent it as this universal set, rectangular shape, and A 1, 2, 3, 4, the circle A 1, 2, 3, 4, and we see that 1, 2, 3, 4, 1, 2, 3, 4 is all these elements of A belong to B, and 5 and 6 are extra elements. So this is B. Here 1, 2, 3, 4 elements belong to also B, and extra 5 and 6 the elements which lie in B but not lie in A. So 1, 2, 3, 4 is the 5, 6, and the universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is universal set. This is A, set A, the set B. In B set, all the elements 1, 2, 3, 4, 5, 6 also lie in B, and 1, 2, 3, 4 only lie in A. So this is the representation of Venn diagram, and again the properties of union. Next one is properties of operations. So first one is properties of union. In this property, first one is commutative property. Commutative property means if there are two sets A and B, then A union B is equal to B union A. So this is commutative property. And the next one is associative property. Suppose A, B, C are sets, then A union B union C is equal to A union B union C. So this is associative property. Next one is law null set, means A union phi is equal to A union phi is equal to A. And next one is idempotent, and this property is called idempotent, means A union A is equal to A, means union of itself is the set also. Next, E is law of universal set. Law of universal set means A union universal set U is equal to U. A union universal set U is equal to U. So this is the properties, these are the properties of union sets. The next one, properties of operations of intersection. So properties of operation of intersection. So the first one is commutative property. Commutative property. means A intersection B intersection C is equal to A intersection B intersection C. Next, law of phi set means null set. A intersection phi means phi. A intersection phi means phi. And the next one is idempotent law means A intersection A is equal to A. And the next one is law of universal set. Law of universal set means A intersection U is universal set is equal to A. So these are the properties of operations on intersection, and these are the properties of operations on union. So we can see that union means if we join two or more sets. So union is always greater sets, and the intersection means the common point. So intersection always less set. So these are the topics of on sets, operations, and difference of sets, complement of set, Venn diagrams,